14-10. To me, this is when it kind of starts making a little bit more sense when you're actually taking some data, that you have here and running your analysis and getting actual information that you could use then to make some decisions. So here we've got, we want to know, we've got worker, right, job performance, okay, what their aptitude is based on a test score and whether they're a union member or not, okay, and leave a column because eventually you're going to do this interaction. And what we want to do here then is, well, let's just go through the questions. If it says A uses statistical software package to develop a multiple regression equation using the job performance score as the dependent variable and aptitude test score and union membership as independent. Okay, so right now I just want these three. Okay, and performance then it says is my dependent variable, right? Because we want to see if performance is dependent on aptitude and union and or union membership. Okay, and so these are my independent variables. Okay, so how do I do this? Well, we go to data, and of course you have to do your add-in data analysis and use the regression. Okay, you can see I've already done it, but I'll kind of go through it again. So my y input, my y range is my dependent variable. Okay, so performance in this case, the y range is my dependent variable. My x range are my independent variables. Okay, and so in this case I want to grab those. And I do like labels on these because then I get down here and it kind of labels it and tells me a little better. And so I'll click on the labels one. It doesn't give me the, I don't think it tells me at the significance level. And so if it doesn't tell us, I think we use the 5% automatically, or the 95.05 or 95%. Okay, and then you put it as an output range, and I've already got it here. I'm going to just put it on a new worksheet just to show you that now I've done all that, and boom, put it up, and there you have it. It's that simple. It's that fast, and Excel just does all the work for you. So okay, hopefully that matches up with what I have on there. Let's see if the multiple R is 0.73. Oopsie, hit the wrong button there. Yeah. Okay, so then A says after that it says use statistical software package equation using, and then develop a multiple regression equation. So here's, you got to do this, right? And again, it's relatively simple when you do this. The y-hat, or the intercept, okay, is, or I'm sorry, the y-hat is equal to the intercept plus, and these are both positive numbers, so they're both pluses, okay, 5.22 and 22.14, okay, are numbers that go in there. And we can make that kind of a nice color. Okay, then B asks, comment on the regression equation. Be sure to include the coefficient of determination and the effect of union membership. Are these two variables effective in explaining the variation in job performance? So we're using some data that's up here, and the coefficient of determination is our R square. Okay, it's our R square, and I use R2D2 without the D2. Okay, and so there is a positive relationship. Again, it's because the number is positive for one, and we would say that it's moderate. And go back again to that chart, right? If we're positive and we're from 0 to about 0.33 or about 1/3, it's minimal. The midpoint around there is going to be moderate, and then when you get above 0.67 or so, we would say that it's pretty strong. And so the independent variables account for about 53%, is what that's telling us. 53.3%, right, of the performance. Okay, and then we can also tell that union membership increases performance by about 22%. That's what this coefficient tells us. Okay, so we get a lot of information, and fortunately Excel does a lot of the work for us. So then the next question is C. conduct a test of hypothesis to determine if union membership should be included as an independent variable. So we're going to reject the null if t is greater than 2.179 or t is less than its two-tailed test. Okay, and so we want to go back to the back of our book, and we're going to use, let me check and make sure. I was going to say we're going to use 14, I believe, as our degrees of freedom on this two-tailed test. And the numerator should be 2, right? And our denominator let's see. Oh, I'm looking at the F distribution. That doesn't do me much good, does it? I don't care about the numerator and denominator. Well, I actually, what's it say here? C, connect, to determine if union membership, I'm sorry. Okay, so union membership is just the residual then that we use when we're calculating that. And when we're looking for the t-value, the critical t-value. So we use that 12. And if you go to the back of the book, page 734, and we use our degree of freedom as 12 and the 0.05 significance level for a two-tailed test, we get that 2.179. So sorry about that. Looking up those things sometimes is a pain. I'm sure you guys find it that way as well, and trying to figure out some of those things. So okay, and t then is given to us, right? When we're looking at the union membership, it gives us our t. And our t is, in fact, 2.5, and it's greater than 2.179. And so we reject the null, and we accept the alternative. And then we make this statement that union membership is confirmed as having a relationship. So we would not exclude it then from our analysis. Then it asks us to, in D, it says repeat the analysis considering a possible interaction terms. And what are interaction terms? Well, simply all we have to do for our interaction is multiply one by the other. There you have it, and we drag that down. And these are interactions, and then we run a regression again, and interaction becomes another independent variable, basically, and then we see what happens. It changes our other coefficients, which is kind of interesting. And let's take a look here. Let's do that quick. So we got our data analysis, regression, okay. Our y input range stays the same. Our x input range, then we have to include the interaction, okay, and we have labels, yep, 0.05%. And we'll put this on a new workbook. I have it on this sheet actually, but we'll put this here, take a look at it. There you go. You see that kind of changes, some of these other coefficients and whatnot. I don't think it changes how we would make decisions. They're still an R-square that's very positive. And let's come back here. Oops, I'm sorry. Go back to here. And repeat the analysis considering possible interaction terms. It doesn't really ask us to answer anything, but D, okay, let's take a look at this, because we can come to a conclusion, and I would like you guys to do that. In terms of the interaction, we can come to conclusions oftentimes just using our p-value, right? And anytime we get a p-value actually that's kind of north of a really small number, the intercept here is a fairly small number, and so we would say, yeah, okay, but D is we cannot reject the null because the p-value is relatively high, right? I mean, look at the union one, you definitely cannot reject it. The aptitude one, even, we may not reject. Okay, we're usually looking for p-values that are in the 0.0 whatever to I think 0.1 is kind of the upper limit. So this one would be close, but it's still probably high. So we cannot reject the null because the p-value is relatively high, and we would say that there's no significant interaction.